I need to check if Nkululeko is here. Nkululeko. I'm actually looking for Nkululeko. If Nkululeko can actually come on. Nkululeko. That's actually who I'm looking for here. Nkululeko is not here. So Nkululeko is not here. I wanted to get him here, but I guess he's not here. Mr. Chunky boy. Chunky man. Chunky guy, good man, and Gaukhaelo. The Legacy 24. Zamani. Some of you use your names Zamani. Oh, go Zamani. Try sing Zaman. This is so funny. Legacy 24. The legacy begins. Miss Maponya, you guys still writing? Who's writing still this coming week? Grade 11 maths. Is there anyone who's writing in the coming week? HM course. He's still writing in the coming week. Kaylin is still writing in the coming week. The Legacy 24 is still writing in the coming week. Anyone writing in the coming week? Charles Walker. Charles Walk. Oh, okay. I thought maybe you're writing in the coming week. HM Goss, familiar, grade, is it grade, what grade? Grade 11, 12, grade 10. Hello, you're not writing in the coming week, are you? Miss Maponya. Oh, grade 12, HM Goss. Are you in grade 12 this year? Are you in grade 12 improving? Oh, you're not writing this coming week. Okay. So what's happening this coming week then, school-wise? Are you guys going to school? Are you having a week off? Are you going to school to continue with term 2? What's happening? What are you guys all going to be doing in your respective schools in this coming week? Or grade 12 this year? How was your term 1 or continuing? How was your term 1 control test? How did that go? How did that treat you? Yes, yeah. Better but not great. Oh, okay. Yeah, and you guys are coming, you're going to be going in hard to a very very short term this coming term. A lot of holidays, but also simultaneously, like you guys have June exams coming up. June exams, full exams, paper one, paper two, sort of like set up. So yeah, hopefully your grade 11 is still good. And I mean for all topics, geometry, analytical geometry, yeah, trigonometry, all your grade 11 content is still good. Probability for paper one, grade 11 probability, financial maths, yeah, and the works. Because all of those things, June exams, they'll be tested. So hopefully you are ready. You are ready. You are ready. Trigonometry is struggling. So is that grade 11 geometry, trigonometry, or grade 12 trigonometry? You're struggling with both? Offense. Which grade are you in? Offense and Mia? No. This is no grade. I'm just having a conversation with people, just trying to see what's happening. Both grade 11 and grade 10. HM Miss Ngozi.
Hello.
How are you, HM Miss Ngozi?
Yes, I am.
You are struggling with both trigonometries, grade 11 and grade 12.
Yeah, I can't even understand what's happening. I have to go through all past papers in order to write any question paper.
Okay. And so, what were you intending to do about it? Because you actually have some time, obviously, during the holidays to ensure that that's fine, that's taken care of. So, what were you gonna do about it?
I'm doing extra classes, as you can see. I'm joining each and every live show to understand each and every math questions.
Okay. All right. So, I guess then my question will go back to like the basics for trigonometry. So like when it comes down to the basics, obviously you understand like the like everything that's there, Cartesian plane, um, function values, co-function values. You understand all of that.
Yeah, I do understand that, just that I don't understand when it's asked on a question, maybe if they say find the general solution of it.
Oh, okay. So 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 you so you so then if I was to just go through it then, like if I look at the different types, especially for grade 12, let me just check out some exam type questions here. Because you're saying both are an issue. Um just want to check some exam questions here. Not exam type, yeah. Okay. I'm looking at this for instance. So with these questions, I think they call them Pythagoras type questions, these ones. Where you have to sketch a diagram. Do you see these kinds of questions, these ones?
Yeah, I can see.
Yeah, so if you are given tan theta is equal to 5 over 12, and then they tell you sine theta is less than 0, and then they say with the aid of a sketch, without using a calculator, determine the value of sine 90 plus theta. So obviously this is like grade 11, but I can add a question to this one
That's a
to
little
make
bit.
it also so that it accommodates grade 12. You're saying the network is not good.
I think there's a bad connection here because I can't see properly what you're doing.
Okay, so you can't see the question because I haven't done anything yet. I was just pointing to the question.
Yeah, that's what I'm saying. I can't see the question properly.
Oh, so you can't see this at all.
Okay, now I can see since you zoomed it.
Okay, so tan theta is equal to 5 over 12.
Yeah.
And then they say
Yes.
sine theta is less than 0. Okay, so they say is equal to 5 over 12. And then they say sine of theta is less than 0. Okay, then they say you need to draw a sketch using this information. So what would I do here? Well, from your understanding, what would I do? Tan theta is 5 over
I would
12
do
and sine of,
Pythagoras first.
okay. Okay, so lead me.
Yes.
Give me the direction and I'll follow your direction so that I can see that you understand.
First you do cause you can see that 5 and 12 are positive, meaning that
Okay.
the x and the y are positive, meaning they're at the first quadrant or at the dead quadrant.
Okay. So that's the first or the third quadrant. Okay. And then there's this piece of
Yes.
information. Sine theta is less than 0.
I don't know.
Okay. So what does if something is less than 0, it means it is
Negative.
exactly. So that means sine is negative. So my question then to you, where
You're
is
cutting
sine?
again.
Okay. So it means sine is negative. So then the question, where is sine negative? Which quadrant?
Ma? Like ikhathile.
Okay, maybe then you can listen in. You can mute your side and then you can listen in. Okay, so lunatic, you are correct
Okay.
there. Yeah. So sine is negative in which quadrant?
What's this? The second and the fourth one.
Sine is negative in the second and the fourth. Are you sure in the second?
No, 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 no. In the, what's this? The last two quadrants.
Okay, so the second and the third and the
Fourth
fourth.
quadrant.
Yeah. Okay, so you're 100%. So it's the third and the fourth. And so obviously the diagram will be in which quadrant? You
At the
can see
dead
where the,
quadrant.
yeah. So then of course we are going to draw our terminal arm and then obviously complete the 90-degree angle triangle in the fourth quadrant with the standard angle theta. All right. And then our reference angle, of course, which we obviously know will be in the 180 plus theta quadrant. Okay. Now here, you said y and x are what? You said y is what and x is what? So y is,
It's negative.
okay, negative, and then x,
Negative.
okay. And then you did say something about how do we find the third side, which is the hypotenuse, the value of
The
r.
Pythagoras.
Okay. So you tell me, what do I say? Because I hear what you're saying, but I don't, I might not know what you're saying. So what do I
R
write down?
R
R.
equals to the root. You put the root y squared inside the root y squared plus x
Mhm.
squared.
Oh, okay. All right, then.
Yes. Then you put the decimals again. For the y, you put the minus 5 squared.
Okay, minus 5 squared. Yeah.
First, put the root on top of it first so that I can notice what you're doing.
Okay, the root there.
Plus,
Uh-huh.
then brackets again, 12 minus 12
Okay.
squared.
All right. Then.
Yeah. Then r equals, again, put the root. Mamang kung boleh calculator lang. It's 169
Oh wow, that's amazing. 169. Was that the
equals to
calculator?
R13. No, I didn't use the calculator. R13. The R always stays positive.
Okay. Oh wow, that's amazing. Okay, R is always positive. Just future food for thought. All right. So I'm sure you also know that there's always a plus minus here if you take the square root for an equation. But of course, like
Okay.
you said, R is always positive, as you said.
Yes.
Yeah, okay. All right. And obviously, from Pythagoras, this is basically what you had initially, because the square of the hypotenuse is equal to the sum of the square of the other two sides. So obviously, you then took the square root on both sides so that you could find r, which is amazing. Okay, thank you. Right, so I've got
Yeah.
13. Now I can populate my right angle triangle. I have all three sides. Thank you very much. The question asked that I find the value of sine 90 degrees plus theta. How do I proceed?
Okay, what I've learned that the sine turns into a minus cos theta.
The sine changes into a minus cos theta, if you are saying so. Okay. Where does the
Yes,
minus
yes.
sign come from? I want to ask that first.
Cause I'm seeing the 90 plus degree
Okay.
theta, meaning cause it's gonna go to the the second quadrant, and in the next quadrant there's a negative what's this x's, so that means
Okay.
the cos has to be negative.
Okay. I want to read you what you've just said. You
Yeah,
said 90 plus is in which quadrant?
it goes to the second quadrant.
Okay. 90 plus is in the second quadrant. In the second
Yes,
quadrant. What is the
yeah.
value? How is sine in the second quadrant?
I don't know.
What do you mean you don't know?
I only heard that when the teacher said the easy way to find it is because we see the plus on this 90 degrees. It means it's gonna go to the second quadrant. In the second quadrant, the x is negative.
Okay. The x is negative.
Yeah.
Okay. All right. So when you evaluate the trigonometric ratio 90 plus, okay, so 90 plus obviously is a
Yeah.
co-function. So sine will change to cos, of course, because of 90. So I
Yeah.
agree with that. I agree. I mean, I fully agree with this part, no doubt. I am full on agreement. And the theta angle, we drop the 90 plus, we take the acute angle. I fully agree with that. I just have a problem with this the sign.
Yeah.
The thing is 90 plus is in the second quadrant.
Yes.
In this quadrant, who is positive in this quadrant?
The sign.
Which trig ratio? Yeah. So we were dealing with sign. So we ask 90 plus in the second quadrant, is it positive or negative? And we say it is.
Negative.
Is sign negative in the second quadrant?
It's positive.
Yeah. So that's why I don't agree fully. Yes, it's positive in the second quadrant.
Okay.
Yeah. Okay. So we always,
So
I
does
mean, we are
cos
always
never
using.
change to the 90 degrees plus?
Say that again.
So doesn't cos changes like for when it says 90 degrees minus theta, doesn't it change as well to a negative?
If it was so what you're asking, are you asking a different question? Are you saying if it was sine 90 minus theta?
Yes, wouldn't it change to a minus cos?
Okay, let's check again. So 90 minus is in which quadrant? It's in the
First quadrant.
first quadrant. How is
Yes.
sine in the first quadrant?
Positive.
So then the answer would be positive cos theta.
Oh, okay.
Are you seeing what we're doing here all the time?
Yeah, I
Because even
get.
here, so let's leave the co-function value. Let's just go to something different. This is 180 minus theta. It's not a co-function value. It's a function value.
Yes.
So
It's
180
gonna be
minus.
sine theta.
Okay, it would be sine theta. Okay, now my question is, how did you know it's positive?
Because on the second quadrant,
Mhm.
the y-axis are still positive.
Okay, the y-axis is still positive.
Yeah,
Okay.
at the second quadrant, even at the first one, they're still positive.
Okay. All right. Okay. I hear what you're saying. I hear what you're saying. All right, let's come back then, because we're not done for this question. 90 plus theta, we got positive cos theta. Now we need to use the diagram and substitute. What is cos theta if we use the ratios for the diagram? Cos is HM cos, are you still there? Hello. Okay, I think we lost connection there. Okay, guys. So for cos, just as I was asking here, cos theta, obviously the ratio that we are going to use, the definition that we're going to use in terms of x and r, cos is x over r, right? X over r. So that means cos negative 12 over 13. Are you with me? Negative 12, because that's the adjacent side, over 13. That is the hypotenuse. So our answer would be negative 12 over 13. Okay. Are you guys breathing the same air as I'm breathing? Or are we breathing different air? Seems like I'm seeing like a couple of requests. People are requesting. Okay, I just want to check what the people. I don't know if HM goes. I hope you in the comment section you can comment if there's something that like I hope that's clear for you. Which we're breathing the same air. Yes, definitely. If it's lunatic, no doubt. Angel, my goodness, we have angels in the mix as well. Angel,
Hi, sir.
how are you?
I'm good, thanks, and yourself?
No, I'm doing okay. Doing okay.
Yeah.
Are we breathing the same air? I don't know. Like I'm on Earth and I'm breathing the air on Earth. I don't know if you're in heaven. You're breathing the air in heaven as an angel.
Yeah, it's the same one, sir. It's the same
Oh, it's the
one.
same. Oh, I like that.
Yes.
Nice. On Earth as it is in heaven. That's what we say, right?
Yeah.
Okay. So I don't know. Did you request because there's you wanted to also participate, comment, or do you have a question?
No, I wanted to participate in like the activities because like trig is a problem.
Oh, check the problem.
Yes.
Okay. Okay. No, I hear. All right. Unako Sony is saying, I don't understand at all. All right. So I'm just gonna backtrack a little bit, Angel. I hope you can allow me to backtrack just a bit. So in this question, Pythagoras type, we had a trig. We have a trig ratio here. Tan theta is equal to 5/12 unako. Tan theta is equal to 5/12. Tan theta, tan is the ratio 5/12 is a positive value. So since it's positive, we then conclude tan is positive. Then we ask, where is tan positive? We tick the quadrants where tan is positive. It is positive, black ticks, black ticks. My black ticks, they were indication of tan being positive. Hey, my phone is doing funny things, my goodness. There we go. Okay, there we go. So black ticks means tan is positive in the first and the third quadrant. Then second point that we utilize, sine theta is less than 0. What does that mean? It means sine is negative, because anything that's less than 0 means it is negative. So sine is negative. But where is it negative? It's negative in the third and the fourth quadrant. Red ticks represent sine is negative. So there. But then we ask ourselves, where do we find our most ticks? They are there in the third quadrant. So that means that the quadrant where we are going to sketch our right angle triangle, our terminal arm will exist in the third quadrant. So there it is. Then we complete our right angle triangle in the third quadrant. Then we utilize this ratio, 5/12. Remember, tan is adjacent, opposite over adjacent. In other words, y over x. The y value is 5, right? Over 12. X is 12. But in this quadrant, we know that y is actually negative, and the x is actually negative as well. So therefore, it is that negative and that negative divided together that give us a positive 5/12. That's why we have positive 5/12, the negative and the negative. We use Pythagoras to then find the missing side, which is r. So there we use Pythagoras. R squared is equal to x squared plus y squared. We substitute the y, which is -5. Substitute the x, which is -12. We square it. We get 25 plus 144, which is 169. We then get the square root of 169, which is 13. And our r value, even though we know this is plus minus, plus minus, plus minus, eventually our r value is always positive. So therefore, that's why we say r is equal to 13. When we write 13, we write it as a positive 13, not a negative 13 in the third quadrant. R is always positive in each quadrant. So R is always positive. That's what we note. Then go and answer the question, because we need to use this diagram to answer the question. Sine of 90 plus theta. This is a co-function value, a co-ratio. So 90 plus, 90 minus, 270 plus, and 270 minus always result in a change. So if we have sine, sine changes to cos. If we have cos, cos changes to sine. So there's always this change between sine and cos for 90 plus, 90 minus, 270 minus, and 270 plus. So that's why we note that for 90 plus is in which quadrant? It is in the second quadrant. That's where in the second quadrant, sine is actually positive. So then we write positive, the changed ratio from sine to cos, and then the acute angle. Then from there, we go to our beautiful right angle triangle and we read from the diagram what is cos. Remember, cos in terms of x and r is x over r. In other words, adjacent over hypotenuse. So that means we are going to displace or replace cos theta with the ratio, the numerical ratio, which is -12, that's the adjacent side, or x over r, which is 13. So that's why we have -12 over 13, and then that basically gives us the answer, -12 over 13. Okay. Angel, I don't know if there's anything you'd like to ask, add, subtract, or multiply.
So, my question is that, like, if you have theta as 2 theta, like, by the angle, do you write it as 2 theta or do you just have to write it as theta?
Okay, say that again. Repeat that again.
So for this, let's say it becomes the
So if
question
you had a
asks
question,
us that 2 theta is equal to 5 over 2. So by the diagram, do you write the angle as 2 theta or is it as theta?
yes, you're right. You write it as 2 theta, the
Oh,
angle.
okay. Okay.
Yes, because
Thanks.
so and I'm guessing that would be you would be asking this question as a grade 12 learner. Is this am I or are you
Yes.
asking this as a grade? Yes, because if you're a grade 12 learner, you will ask that kind of question. If you're a grade 11 learner, you will never ask me that question. So it's different levels, right? Different
Yes.
levels. And I think just for the purpose of what you've asked, let me divert to something of that, like sort of something similar to what you've just asked. Okay, because it's a good question to ask, right? Because you have to, if in the question they ask you this, then you need to obviously in the diagram it has to appear as that theta. But then if in a question in grade 12 they ask you tan 2 theta, then it means that that angle is not theta, it's 2 theta. All right. And therefore you can answer questions that have 2 theta as per the diagram and as per what has been stated in the statement. So it's very important that you make that distinction. And I think a lot of people are actually finding themselves fall short when they don't actually, they're not aware of that. So it's good awareness. I'm just trying to look for a nice, sweet, said, because it's good that you asked that thing.
So if you check the
So are you in grade 12, Angel, at the moment?
Yes.
Or are you
Yes.
improving? There are a lot of people that
I'm currently in grade 12.
oh there we are. There it is. Here's a question that's here. Oh, you're currently in grade 12. Okay, nice. Nice. And how's that treating you? All right, I've somehow missed or lost the question here. Okay, so here it is. Let me just. So this one would be relevant for a grade 12 learner, like a grade 11s. But since grade 11s are here, so if tan 2 theta is equal to minus 24 over 7, where 0 degrees find without a calculator the value of okay. So you see that it says if tan 2 theta is equal to minus 24 over 7, where 2 theta is between 0 and 90 degrees, then it says find without using a calculator the value of, and the values that they want is cos 2 theta. Yeah. All right. And then also number 2, they want cos of theta as well. Okay. So then the question is, how do we maneuver here? If tan to theta is equal to negative 24/7, where 2 theta is between 0 and 90 degrees, they say find without a calculator, using a calculator, value of cos 2 theta and cos theta. So, Angel, do you want to lead me?
I think is to first identify where 10 is negative. So identify where
Very good.
and it's negative in the second and the third. It's the second and the fourth quadrant.
Okay. Second and fourth, definitely. So we're
Yes.
done there.
Then you also have to take where 2 theta.
Sorry, there's just something that I actually wrote down incorrectly. It was
Okay, yeah.
0 to 180, not 0 to 90.
Yeah, from 0 to 180, which is going to be the first and the second quadrant.
First and the second
Yes.
quadrant. Okay, then.
Therefore, our diagram is going to be in the second quadrant.
Epic. Second quadrant. There we are. Terminal arm. Then completing the right angle triangle. Then that's our angle 2 theta.
Okay, yeah.
So negative 24/7.
Negative 24 is going to be the y.
The y-axis.
Yeah, it's going to be negative because it's the opposite. Opposite over adjacent,
Okay.
I think.
So I'm just going to put 24.
Yeah, 24, then it's going to be negative 7.
Okay, definitely. So are we all clear about why we didn't insist on this being negative? Even though, like we can see here, it's negative 24 there. But remember, at the end of the day, it's like negative divided by positive gives us a negative fraction. But ultimately, when we look at the diagram, we have to attach the sign to the relevant coordinate according to our x or y. So definitely our y here has to be positive, and then our x here has to be negative. Okay, then
Then we're gonna have to do Pythagoras to find the hypotenuse, which is going to be r squared is equal to 24 squared plus negative 7 squared.
Okay.
Which is 24 squared. 24 squared is 576.
Okay.
Plus negative 7 squared is 49.
Okay, epic.
Then all of that is going to be r squared is equal to 625.
Okay.
Therefore, r is equal to 25.
Okay. R is equal to 25. Nice. Okay, complete my diagram there. Seems like I've got all my sides. Diagram's complete. I need to answer the question. The first one was cos 2 theta.
Cos 2 theta is going to be is going to be 7 over 25.
Cos 2 theta is going to be, say that again.
Negative 7 over 25.
Okay. Negative 7 over 25. Okay, I love it for you. Epic. And you know what? I give you a tick for your efforts. In fact, I give you a tick for your efforts as well with the Pythagoras. Okay, then we need to answer the second question. Cos theta.
I don't know this one.
You don't know this one?
I know.
How can you not know something but it knows you?
The problem is that we have 2 theta, and here the only one they want cos theta. Like,
Yes.
I don't know. I would leave it
You'd leave it, eh?
open in a test.
No, don't do it. All right, let's think for a little bit. Cos 2 theta. Do you know this is what kind of angle it's a?
It's a compound.
No.
I think.
No.
I don't know.
It's a double
angle.
Yes. There is an expression for all the double angles. There's 3 expressions for the double angle cos. 3 of them. There's one that has cos in it.
It's 2.
Yes. It is?
It's 2 that have cos.
Yes. No, 3.
Oh.
Hey. I'll tell you things. Look. Cos 2 theta can be written as, what's nice is that all these 3 are in the formula sheet, so it's not like you have to know them off by heart. There's this one, 1 minus 2 sine squared theta. Then there's this one, cos squared theta minus sine squared theta. Then there's this one, 2 cos squared theta minus 1. Do you remember these 3?
Yes.
Please, angel. Be an angel for me and know all of them. Like, seriously. Because when you know all 3, then, or at least you are aware that there are 3, and then you have your formula sheet. Remember, when you guys write the exams, you have the formula sheet available to be used by you. So all 3 of them are there. And you always utilize the one that is appropriate for a particular situation. You look at the situation surrounding whatever you are doing, and then you utilize the one that will actually help you in that situation. So for instance, I'm not going to even bother about this, the first one. Goodbye. I don't have time for you. All right.
Is this for the first or second question?
This is for the second question.
How?
I don't have time. This guy is equal to this guy.
I think there's something wrong with the network.
Oh, is it? Is she? The funny thing is my network says good, and then, okay. It also says, okay.
No, it's back. It
keeps on chopping and changing. Let me know.
Yeah.
It's back now. Hey.
Yes.
But it's on and off, isn't it?
Yeah, it was. Yeah, now it's back.
Okay. So cos 2 theta is equal to minus 7 over 25, right?
Mm-hmm. Yes.
Right?
Yes.
What if we wrote this thing here and we wrote 2 cos squared theta minus 1 is equal to negative 7 over 25? Would we be correct?
Yes, because that's the double
Yes, it would
compound
be.
angle.
Yes, because this is the expression of the double angle, right?
Yes.
And it's equal to negative 7 over 25, right?
Yes.
Then let us transpose the negative 1 to become positive 1 this side. Then let's isolate the 2 cos squared theta. Do you see where we're going?
Yes. Then
Do you
we're gonna
like where we're
divide
going?
everything by
I
2.
hope you do. Yes, see. Oh, man. Then after that, after dividing everything by 2, I'm gonna do what?
I don't know.
Over. There it is, minus 7 over 25. You add the 1. You get the what? 18 over 25. Do you see that? Then you divide by 2, right? Because you are going to divide by 2 both sides. Then you divide that by 2, right? You get
Take
9 over 25.
Yes.
Yeah, but remember, at the stage where you get 9 over 25, you are actually at this stage. Cos squared theta is equal to 9 over 25 because you just divided by the 2, right? Then
Don't
now
you
you
root
can
it?
do what? Take the... Yes. My
Okay.
goodness. Chini. Don't mess around with you.
But then it's gonna be 3 over 5.
Yeah.
Okay.
Don't mess with you. Okay. Because I'm sure you were wondering in your head, how am I going to get theta? Whereas in my diagram, I have 2
2
theta,
cos
right?
theta. Yes.
Yeah, because in your head, you were like, but the diagram doesn't have theta. The diagram, it has 2 theta. So that's where your expressions of the double angles come into action.
So wouldn't I have gotten like maybe, I don't know, I haven't tried it. But then wouldn't I have gotten the same answer if I yeah, no, I will know this would have been wrong, but then I divided the one with cos 2 theta by the answer by 2.
I know, no. Remember, Angel, that this here, this you can't do this. This double angle, you cannot divide by 2 for the angle. You can't. It's mathematically incorrect because this 2 is the coefficient of the angle. So who needs to leave before you can metric
Cos.
ratio? Yes. So you can't divide by 2 when cos is still in place. Sorry. So you would have been completely wrong had you done that.
Oh, okay.
And I know in your head, though, it would have been like, yes, I'm getting to the answer. but, but then it would have been completely wrong. So you need to be careful about situations like that. Eh?
Yeah.
Yeah. Okay. At least we answered a question that you had that was sort of like at the top of your head in the moment. So, okay. Any further questions, Your Honor?
My questions actually with the whole of trigonometry is like, it's not like with one thing.
Yeah,
That's right.
but you see something I've picked up just from the questions that we've just done is that it to me it also seems like maybe you're not really aware of all the 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 what is it, all of the expressions that are there, that are available in the formula sheet, that you need to know in order to be able to do certain questions. Because if you're not aware of
Mm.
those, then it's going to be very hard for you to actually even do something. For instance, I'm just thinking of this question. You would have stopped after the first question. After getting cos 2 theta, you would have been fine, and it would have been very difficult for you to get cos theta. Why? Because you don't know all the three expressions of the double angle of cos. So just be aware of those. Like, know all the expressions of the double angles. There's something funny I usually say to everyone that like comes onto the live, and I usually say, please take down the Chris Brown off your wall. Yeah, the Chris Brown, the Casper Nyovest, like take them down. I know like a lot of you idolize these people, you have them on your wall. But right now, like if you're in matric, of course, and you're writing like major exams, you're gonna be writing, you're gonna be repeating these things, you're gonna be writing them in June, you're gonna be writing during the trial, you're gonna repeat them again in the final exams. You want to have those things that will commonly actually appear on your wall, constantly seeing them. You come into your room after a long day, there they are, bam, it's like they welcome you. So like have those things that will commonly appear, have them up on your wall, have them behind your toilet door, have them on the fridge. Like, I know it's kind of absurd, but like because you want to be familiar,
Mm.
and not forget. They need to be in your face.
I don't know if you have the what is it called? The mind action series.
Yeah, the mind action series textbook, yes.
Like it's by exercise number. I think it's exercise number 3 whereby it's exercise number 4 on page 152. It's talking about proving the compound angles, right?
Okay.
C. It says that given that cos A minus B is equal to cos A times B plus
Hey, wait.
sine A.
Hold up. Go back. Given cos A minus B.
Yes, is equal to cos A times cos B.
Okay.
Plus sine A plus times sine B.
Yes.
Then the first question says prove that cos A plus B is equal to sine cos A times cos B minus sine A sine B.
Prove that cos A plus B is equal to cos A times cos B
Minus sine A sine B.
Amen. Okay, I see this question. So then you are asking yourself the question, how do you do that?
So what I would have done is that I would have just I would just have said left hand side, then expanded it, then said right hand side is equal to left hand side. I don't know.
Okay, so here's the thing. The trick here, Angel, I hear what you said you would have done. You are given this. This is what you are given. Right? Now they want you to prove using this. You need to use this and prove that cos A plus B is actually equal to that. Check this out. So this is your like your template. This one. This is your template. This one. This is your template. So we're gonna come here. You see this cos A plus B. This A plus B can be written as A minus B.
Yes.
Do you agree?
Yeah.
This plus,
Yes.
I just changed it to minus b. Why did I change it to minus b? Because I'm seeing this. This
Yes.
b, all right, is fine. It's just, but the thing is, the minus sign is there, which is basically, I can now use this template and write this here in terms of this there. Now check me out. So cos A is obviously from the A there. So I'm going to do that. Cos A times. But then I would write cos B because you know what I mean?
No.
This does not show, my goodness, what's happening. Cos A minus B. So it's cos A cos B. So from this here, it's cos A cos B, right?
Yes.
But then the B here, okay, this B here, right? Look, there's a, here it's minus B, here it's minus B. So that means this B is going to be written as what? As a negative B.
Oh,
Instead
therefore
of it
just
being,
becomes cos B.
yeah, exactly. Yeah.
Oh, okay.
But wait for me to finish. Okay, so wait for me to finish.
Okay.
So cos B, right? Then this plus, obviously, because there's a minus sign, we know that this minus sign, it will change. It will become positive. So of course, here it's also a minus sign. So that means that will also be a positive.
No, yeah, plus sign.
And then we are going to have sine of A, all right? Sine of negative B.
Negative B.
Yeah. Okay. So far, we're good. Are we okay?
Yes.
Let's finish off now. Cos A times cos B. That basically gives me cos A. But we know that the negative angle B for cos, that's like, this is in the fourth quadrant, right? Yes, 360 minus B. But cos is what in the fourth quadrant? It is
It's positive.
positive. Yeah, so we just write cos B when we evaluate this.
Yes.
Plus sine A. Now here is where things change. Sine of negative B, we add 360. This is in the fourth quadrant. Sine in the fourth quadrant is
Minus negative sign.
Are we flowing together so far?
Yes.
Can I now finish off? This is positive, no problem. But a positive times a negative gives me a what?
A negative.
Exactly. So I have negative sine A, sine B.
Okay.
Done.
Oh.
Isn't cos A plus B actually equal to this? Yeah, it is. So I've proven it. There, I've proven it. Using this template, because this is my template. What I'm given is my template. So I simply just manipulated cos A minus B. I just wrote it as cos A minus B. I used it as a template to change cos A plus B to be cos A minus B. Isolate the angle. Then I expressed using the template cos A minus B as this. And then the negative sign were taken care of. And then I was able to get the right-hand side, which is this, what I wanted to prove.
So do you also do it the same with the cos compound angles?
The cos compound angle. So this was a cos compound angle.
Not the cos, the sine. Sorry.
Yeah, the sign, well, it depends on the question. So once again, it would depend on the question that I'm given. What am I given? So that I can then work on what I've been given and apply something to that so that I can prove it.
So question 2, it says that hence prove that sine
Okay, hang on.
A plus B
Hence prove sine
A plus B
A
is equal to sine A cos B
is equal to sine A cos B
plus cos A sine B.
plus cos A sine B. Okay. Hence. So we must prove henceforward and forevermore that this is actually what they want. Okay. So before I delve into it, do you have any thoughts? Because hence means use something that we have done in the previous question. So I want to ask you, is there anything that comes to mind for you or not? Not really.
Nothing.
Like nothing at all.
Not even a bit.
Okay. All right. Well, if there's nothing at all, then I'm going to help us out then. So here is what we do. So hence, it means we need to go back and check what we did previously so that we can be able to prove that sine A plus B is equal to sine A cos B plus cos A sine B. All right. So I hope you are ready for this. Look at cos 90. Look at sine A plus B. So what I'm going to do, I'm going to take my good old left hand side. Do you remember what I did here? I took my left hand side and I did something to it so that it could mirror this. So I'm going to do the same thing here. I'm going to take this side so that it can mirror something this side. Check what I do. Cos of, I'm taking this. Cos of. And you're like, what? How can you say cos of? But you see, the thing is, there's these things that we called co-ratios. Cos of 90 minus A plus B.
Okay. So you also use this thing when you're proving these angles.
Of course, because how am I going to change sine so that it has this template? There's no ways. Yeah, because this is the template I'm using, right? So
yes.
I have sine of A plus B, and somehow I have to use the left-hand side to prove that it is actually equal to the right-hand side. But how do I do that? So I'm going to revert back to my template. That's what I was given. Okay, so I have cos of 90 minus A into A plus B, close bracket. But it doesn't end there. Check what I do next, because what I do next may probably surprise you. So I say cos of, and deliberately I say 90 minus A. So I take the negative, I distribute it, negative A. Minus, and then what I do is I regroup cos of 90 minus A minus B.
Why?
Because I am looking at this guy and I'm like, there has to be some regrouping happening. You see, the thing is, sine A plus B, I have to get sine A to begin with. If I have cos of 90 minus A plus B and I leave it like this, it's not going to help me. So I need to regroup.
But then what's going to happen to sine B?
Check it out. You check. You want to check? Let me show you now. Now we can use the template, this template.
Okay.
Do you see my first angle? It's 90 minus A. Just like there's an A here. Do you see my second angle? It's minus B. Just like there's minus B there. Do you see?
Yes.
Okay,
yes.
Check it out. Now I'm going to expand it. Are you ready to expand? Okay.
Yeah.
So template, distribute negative sign. rearrange. Okay, so that's what I did. Cos 90 minus AB, template co-ratio. Let me just say that as well. Okay, so here we go now. Now I'm going to expand. Let me expand this. And there is my template. Cos of A, cos of A, then followed by cos of B. So I'm going to say cos of 90 minus A. Cos of B. Do you agree?
Yes.
Then, since there's a minus sign, it means I change that to plus, according to the template. Then followed by sine of 90 minus A, followed by sine of B. Are we still together?
Yes.
Okay, now this is a co-function. 90 minus means cos changes to what?
Sine.
And it's 90 minus, it's in the first quadrant. Cos is positive,
Yes.
so it's sine of A. Followed by
Cos beta. Then
Plus.
it's plus
This is also co-ratio.
cos alpha, cos A,
Thank you. Followed by
sine beta B.
thank you. Isn't that it?
Oh.
Proven. Sine A cos B, sine A cos B. Cos A sine B, cos A sine B. Proven.
Oh. How many marks would this be out of?
How many marks? I don't know. I don't know how many marks it would be. But I'm guessing you're like thinking, yo, it must be a lot of marks.
Yeah.
Well, who knows, eh? Who knows? I actually don't know. Off the top of my head right now, I don't know. Okay, so that's how you would answer those questions. You use you use this as a whatever is given, you use it as a template. All right.
Okay.
As long as there's cos again, it just means there has to be some manipulation with the sign. All right. But if there's a different trig ratio, like from cos to sine, then it means you need to use your co-ratios. All right, your co-functions. Yeah, and then sometimes you may have to rearrange depending on the situation, distribute and rearrange depending on the situation, and then conclude in that fashion. But you will always get that given right-hand side. It is the left-hand side that you need to manipulate so that you can make it to be like the template that you have been given. That what you've been given is your template that you need to utilize to be able to,
Okay.
All right.
I get it.
I get it. Okay. Yo. Angel, you've taken us to 2 minutes past 10. Thank you so much, HM Gose, for the ice cream. Really appreciate it. I mean, ice creams are coming through. Yeah, so much heat. Ice cream really soothes the what. Thank you. Right. Wow. Okay. Nice. I believe if there's nothing else at the moment, Angel, yeah, I'm happy to have question sessions like this. Of course, I must say I hardly do them, but when I do them, I guess people do ask, and it's okay. It's good.
Okay. Not for now. I'm good.
Okay. All right.
Yes.
I'm happy you're good. Well, thanks for bringing your angel goodness into the live. Really appreciate it, and the questions. And thanks for being a good sport.
Thank you so much.
Sure thing. Cheers.
Cheers.
All right. Okay, that was cool. That was nice. That was very well asked. Questions there. So HM wants to come back now. Is that correct? HM wants to come back. I see Mr. Mahlangu as well. Njabulo. Guy with happiness. HM course, what's happening?
Nah, you have answered all my questions. I wanted to join through that
Oh, that
conversation, but you've
kind.
answered all.
Oh,
Yeah.
okay. Okay. Thank you for the ice creams as well and all of that good stuff there. Mr. Njabulo,
Sure, Manier.
the joy bringer.
Sir?
The joy bringer.
Straight, Baba. Change.
Yeah, the one who brings joy. Njabulo. Hey,
Ish. I've got a question, man, on optimization.
optimization. Leadership. You're asking about optimization when I'm not optimized.
Hey, you know, man, these questions, yeah.
The optimization questions, so optimization, that's calculus, right?
Yes.
Oh, okay, I see calculus. Ish. You see, I would say that you actually have me with you have me ill prepared when it comes to calculus as a whole. It's like if you ask me a calculus question right now, I'd be like, what? You know? Yeah, because I'm out of knowledge when it comes to calculus. You know, and you'll be shocked when I say this, and it's true. I'm not gonna beat around the bush and try and whatever. But yeah, you are literally you are finding me ill prepared when it comes to calculus. It's not even in my head.
No problem, Manier.
Yeah. But maybe. You see, the thing is, I'm sure if you ask me that question in 2 weeks' time, no, I'll be ready for you, my leader. I'll be ready for you.
You can write it down, sir.
Yeah.
I can come back.
What does the question say? Let me write it down.
A hotel
Oh, bengihlele hotel. Hey,
has
Mr. Moneymaker. A hotel
72 rooms
has 72 rooms. Okay.
to let to clients.
To let to clients. Uh-huh.
The daily rent per room is 500 rand.
The daily rent. The daily rent is 500.
Yes.
Okay.
Then they say if the rent is increased,
Oh, if the rent is increased. Uh-huh.
by 100 rand per day,
Oh, okay. Uh-huh.
two rooms
Uh-huh.
can be left vacant daily.
Can be left vacant daily. Okay. Uh-huh.
The rent RX
Okay. Yeah.
per room. Oh yeah, the rent is RX per room per day, where X is greater than 500.
Where X is greater than 500.
So
Okay.
the question that I have a challenge with is they are saying show that the total daily income
Total daily income I
is given by I is equal to 82x
yes.
minus x squared divided by 50.
X squared divided by 50.
Yes,
Okay.
that's the question.
Oh, okay. All right. I see. You know what's funny is that as I am looking at this question, I'm like thinking to myself, especially because I'm looking at the concepts that they are talking about here. A hotel has 72 rooms to let to clients. The daily rent is 500. You know, there's a daily rent there. The rent is increased by 100 rent per day. 2 rooms can be left vacant daily, and the rent is X rand per room per day. Where X is, it said where X is greater than 500.
Yes, sir.
Okay, where X is greater than 500. Okay. And now they are asking, show the total daily income.
Yeah.
Okay. And that I is given by 82x minus x squared over 50, ne?
Yes.
Oh, okay. All right. Hi, thanks for the question. My lid, yeah, I think generally, even if you had asked me another question where calculus is concerned, I would have caught me off guard, to be honest. Yeah.
Okay.
Let me tell you something unique about myself. Me, I'm not gonna lie. I don't claim to be a genius when it comes to maths, not even by the list. But I'm someone who really, when I've studied something and I understand the concept behind it, then I'm able to apply the concept and then answer the question. So you are finding me ill prepared because, like I said, it's been a while since I've actually even cast my eyes in the direction of calculus. So optimization, like I'm just having like a remembrance of things in the past, but like I'm underprepared. So what I will do is I'll actually take some time to delve into the topic first, even before I delve into this question of yours. Then when I have actually solidified my understanding, then I'll be able to explain and articulate. Even if, let's say, for instance, I do a video or something like that on this question. But I've noted the question. Thank you so much for asking it.
Okay, thank you very much, sir.
So that means, my little Jabulo, are you in grade 12 or are you...
I'm in college.
You're in college. Oh, okay. All right. So you're doing this, you're doing
it's
this
application
content.
of calculus.
Oh, okay. Neat. What are you intending to teach it?
No,
Oh, okay.
I'm an N5 student.
Oh, okay. Oh, I hear you. No, nice, man. Nice. Okay. No, not a problem, buddy. Thank you so much for asking the question.
Thank you,
And
sir.
I am sorry that I'm not in the position to answer it now, but yeah, in 2 weeks' time, my leader, you. Yeah, I'll be
It's
too
not a
fit.
question I was rushing, but I
Okay,
know it's
all right.
challenging.
Okay. No, but thank you for asking the question. I really appreciate it, bro.
Thank you too, sir.
Sure, Joe. Okay, neat. Okay, guys, thank you so much. That was actually a good question. Thank you. Yeah, and just like I said to Njabulo, please don't get me wrong. I am not, I when I know something, I know it. When I don't know it, I don't know it. But I'll definitely go and actually solidify my content knowledge when it comes to calculus in and of itself, so that in this optimization problem, especially, I can be able to address it at a later time. But thank you for the question. These are things that keep me on my toes very nicely, so I really appreciate it. Guys, I'm going to have to go to bed right now. Yo. Didn't know that I would stay up for this long. I have to put my kids to bed too. Thank you so much. Thank you for all the questions. Thank you for those that joined. Thanks for those that had the courage to come up and ask questions. Much appreciated. Nelly Comfort, Bronco, Tinoshe, Khalimo, Lady Aru, Nindo Koshe. Yeah, Mr. Zuma, you are the man. HM Gosi, thank you as well for the hot meals, the gifts, the joining my team. Really appreciate it. And Jablo Mashang, thank you for the question as well. And Mogamoso, don't worry, I will definitely go ahead now and go and download that video that I did for functions, straight line linear functions. And then tomorrow we'll continue with more things that have to really do with functions. Thank you, guys. Have a good night, and please take care of yourself. Maths is a game, guys.